Hi, welcome back to Moose and Chemistry. This is gas stoichiometry lesson number 3. How many liters of water can be made from 100 grams of oxygen gas with an excess of hydrogen at a pressure of 141 atmospheres at 70 degrees Celsius? First of all, please note that we're using grams here this time instead of moles. So we have to go ahead and convert grams into moles. So we take 100 grams of O2 times 1 mole of O2 divided by 32.00 grams of O2. That cancels, and that gives me 3.125 moles of O2. All right, now we have to do an equation to figure out how many 3.125 moles of O2 make into moles of water. So we need to know the equation. So the equation for it would be 2H2 plus O2 yields 2H2O. How did I know that? Well, because I've done these problems before. And you guys should know how to make water from hydrogen and oxygen. Okay, so now let's go ahead and do this. So we go 3.125 moles of O2, and we want to convert that into moles of water, so we have to look at the molar ratio. The molar ratio between moles of oxygen and water are 1 to 2. So we can put 1 mole of O2 on the bottom and 2 moles of H2 on the top. You get that from the balanced equation. That's going to give me 6.25 moles of H2O. All right, everything's starting to come together now. Oh, look at this. We have 7 degrees Celsius. Can't use that, so we're going to go and box this first thing here. This is important information. Let's box it. Okay, and then we need to take 70 degrees Celsius. So we go K equals C plus 273.15. This problem seems to have quite a few little tricks in it. So we get 70 plus 273.15. So Kelvin is equal to 343.15 K. So that's going to be important. So let's go ahead and box it. We're going to need that later. Definitely so. All right. Now, we've got ATMs. We now have moles. And we now have Kelvin. And all we have to do now is use PV equals Nrt. So PV equals Nrt. So let's look at our players. We've got pressure, volume, moles, universal gas constant, and temperature. Well, the temperature is 343.15 K. R value is 0.0821. That'll be liters times atmospheres over moles times Kelvin. All right. We have our number of moles, which is 6.25. So that's where that information comes in. All right. Our atmosphere is 141 atm, and our volume is unknown. So all we have to do now is isolate for V. These problems can get pretty intense. V equals Nrt over P. All right. So V equals 6.25 moles times our R value, 0.0821 liters times atmospheres over moles times Kelvin, times our temperature, which was 343. I'm going to space there, K, sorry about that, divided by our pressure, which is 141. ATMs will cancel, moles will cancel, Kelvin will cancel, leaving only volume and liters left. And our answer is going to be, of course, 1.25 liters. A lot of work, guys, but we got it done. All right, so now we're going to look at our next problem here. And it says, calculate the mass of potassium chlorate needed to produce 6.02 liters of oxygen at 40 degrees Celsius in 2 atmospheres. Seems like we've got a lot of what we've got to do before. But in this case, I've already written out the equation for you. And we've got liters, so we have volume, and we need to convert, this time, temperature, okay? We're not using grams, so we have liters, so that's good. So let's go here and get the temperature taken care of first. So K equals C plus 273.15. K equals 40 plus 273.15. So K is equal to, of course, our temperature is going to be 313.15 K. All right. So now we can go ahead and set up what we're looking for. So we go PV equals nRT. Let's see if we get all our necessary players. We got P, we got N, we got R, we got T, and we should put a V right there. So our pressure was 218. Our volume was 6.02 liters. Our N is what we're looking for. Our R value is 0.0821 liters times atmospheres over moles times Kelvin, and our temperature 313.15 K. All right, so let's isolate for N. N equals PV over RT. So N equals 218 times 6.02 liters divided by our R value, which is going to be 0.0821 liters times atmospheres over moles times Kelvin times our temperature, which is 313.15 K. All right, so atmospheres cancel atmospheres, liters cancel liters, Kelvin cancels Kelvin, and our N value, put it up here, is equal to 0.47 moles of O2. Now, we're not quite done yet, okay? So what we need to do is we need to look at our equation here. And we're going to want to change the moles of oxygen into mass of potassium chlorate. So we're going to go and do this. We go 0.47 moles of O2, right, times, then we're going to have mole ratios down here. So we got 3 moles down here. We're getting this from the equation, and 2 moles of potassium chlorate on top, right? And then we're going to times that by the molar mass of potassium chlorate, which we need, which happens to be 122, looks like 0.55 of KClO3. Moles cancel moles, even grams, and our answer is going to be 38.40 grams of KClO3. Well, that's it for this lesson, guys. You be snarly. I will see you back here at Moosine Chemistry.